Hi everyone, I welcome you all to the short video lecture on polymers. Today's lecture I will be covering the definition of polymers, classification of polymers, nomenclature of polymers and the types of polymerization reaction. First we will see what is the polymer, the definition of polymer. Polymers are macromolecules. According to IUPAC, that is International Union for Pure and Applied Chemistry, polymers are macromolecules. Macromolecules means giant molecules of high molecular weight. So, how are these polymers formed? Polymers are formed by linking together of large number of small molecules known as monomers. So, monomers are the small molecules which, when it combined together, form a large molecule, macromolecule called polymer. For example, consider a small molecule such as ethene. So, this ethene, when it undergoes polymerization reaction, it forms polyethylene. So, this is our ethene molecule, CH2 double bond CH2. This one polymerization gives polyethylene. Another example is styrene, CH2, CH, and the phenyl group is there. This one polymerization undergoes polymerization reaction and forms polystyrene. So next we see the classification of polymers. Classification of polymers. Polymers can be classified based on their source. Based on source. Polymers can be classified based on structure. Polymers can also be classified on the basis of synthetic method and also based on molecular force. So, polymers can be classified based on their source. Based on the source, polymers can be classified into natural polymers and synthetic polymers. Based on the structure, polymers can be classified into three types: linear polymers, branched polymers, and cross-linked polymers. Based on structure, they can be classified into linear chain polymers, branched polymers and cross-linked polymers. Based on synthetic method of synthesis, it can be classified into addition polymers, condensation polymers, and copolymers, which are formed by copolymerization reaction. Then based on the molecular force which is acting on the structure, it is classified into thermoplastics, thermosetting plastics, elastomers, and fibers. So classification of polymers. Polymers can be classified based on the source. Based on the source, it can be classified into natural polymers and synthetic polymers. Based on the structure, it can be classified into linear polymers, branch chain and cross-linked polymers. Based on the synthetic method, it can be classified into addition polymers, condensation polymers and copolymers. Based on the molecular force, it can be classified into thermoplastics, thermosetting plastics, elastomers and fiber. Next we will see the various nomenclatures that are involved in the polymer chemistry. Nomenclature of polymers. First we will see what is degree of polymerization. Degree of polymerization is nothing but the number of repeating units present in the polymer chain. Degree of polymerization is nothing but the number of repeating units present in the polymer chain. Repeating units present in the present. And degree of polymerization is given by the formula. Degree of polymerization is equal to molecular weight of the polymer divided by molecular weight of the monomer. Molecular weight of the monomer. So this degree of polymerization is nothing but the molecular weight of the polymer divided by molecular weight of the monomer. So molecular weight of polymers usually range between 5,000 to 2 lakhs. It will be the range. Next we will see what is a homopolymer. A homopolymer is a polymer in which all the monomeric units are the same. All the monomers that are in the polymer chain are same. For example, in this case, all the monomeric units are Ml. So such polymers are called homopolymers. Then we have copolymers. Here M2, M1. So when different chemical structures are present in the polymeric chain, then it is a copolymer. When all the monomers are same or are all identical, then it is called a homopolymer. When different chemical structures are present in the polymeric structure, then it is a copolymer. Next we will see what are the linear chain polymers, branch polymers and cross-linked polymers. Linear chain polymer means in the case of linear chain polymer, it's a straight chain. The polymer chain is straight chain. Okay, this is an example of linear chain polymer. Next we have what is called branched chain polymer. In branched chain polymer, the structure is like this. So this is the backbone. This is the backbone of the polymer, and this is the branch. This is the branch structure, and this type of polymer is known as branched chain polymer. And in this case, if the backbone of the monomeric molecules and the branch molecules, if they are different, then it is called. If the monomers present in the backbone of the polymer is different from that of the branch, then it is called graft copolymer. Then it is called graft copolymer. So next we have what is known as cross-linked polymers. So cross-linked polymer. So I am drawing the structure of a cross-linked polymer. 3 different polymer chains are there. And there will be some cross linkages. So this type of structure is known as cross-linked structures. Okay, this type of polymers is known as cross-linked polymer. Next we will see what is known as tacticity. Tacticity means orientation. Orientation of the monomeric molecules in the polymeric chain. Tacticity means orientation of the monomeric units in the polymer chain. So, if all the functional groups are present in the same side of the If all the functional groups are present on the same side of the backbone of the polymer, then it is known as isotactic. Isotactic means if the functional groups are all lying on the same side of the polymeric chain. For example, this is our polymeric chain. And suppose this is these are our function groups. Since all the function groups are lying on the same side of the polymer backbone of the chain, then it is known as isotactic. Then there is another type called atactic. Atactic means the functional groups are arranged in a random manner. Okay. The functional groups are lying in a random manner and there is no order in the arrangement of function groups around the polymer backbone. And there is a third type that is called syndrotactic. In the syndrotactic polymers, the function groups are arranged in an alternate fashion. So, what is tacticity? Tacticity is nothing but the orientation of the monomeric units in the polymeric chain. So it is of two types, isotactic. Isotactic means that the function groups are all lying on the same side of the chain, and isotactic, then we have what is known as atactic. In the case of atactic, the function groups are lying on the, randomly they are surrounding the chain, and in the case of syndrotactic, we have alternate arrangement, the arrangement of function groups in the alternate fashion. So this is about tacticity. So what have we seen till now? We have seen the definition, what are polymers, then we saw what are the different classifications of polymers, then we saw some of the nomenclatures, homopolymers, heteropolymers, tacticity. Next we will see what is known as functionality. Functionality means Next we will see what is known as functionality. Functionality means the number of reactive sites or bonding sites present in the monomeric molecule. For any substance to behave as a monomer, it should have minimum 2 binding sites or reactive sites. For example, our ethylene, any olefin. Olefins have this double bond. This double bond, when it is broken, it can form 2, and there is a cleavage, it can form 2 single bonds. So, this is acting as a bifunctional monomer. Okay. So, what is functionality? Functionality is nothing but the number of reactive sites or bonding sites. Functionality is the number of reactive sites or bonding sites present in the monomer. For any substance to act as a monomer, it should have minimum 2 reactive sites or binding sites. If there are more than 2, then it is known as polyfunctional monomer. If there are 3 reactive sites, then it is called trifunctional. It is known as trifunctional monomer. If there are more than 3, then it is known as polyfunctional monomer. So next we will see what is homochain polymers and heterochain polymers. Just now we saw about functionality. Next we will see about homochain polymers. What are homochain polymers? In homochain polymers, all the atoms present in the polymeric chain are same. Okay, all the atoms present in the polymeric chain are the same, identical. In the case of heterochain polymers, we have different atoms. Different atoms are present in the polymeric chain. In the backbone of the polymer, there are different atoms present. Such polymers are called heterochain polymers. So next we will see the different types of polymerization reactions. As I already told you, polymers can be classified based on the types, method in which it is synthesized. There are 3 different types: addition polymers, condensation polymers and copolymers. We will see the mechanism. We will see the 3 different types and their example. So first we will see what is known as addition polymer. So this types of polymerization. First type is addition. It's also called chain polymerization. Okay. So in the case of addition polymerization, the product or the polymer that is formed is the exact multiple of the original monomeric molecule. In the case of addition polymerization, for example, consider vinyl chloride. This vinyl chloride on polymerization, on addition polymerization, this polymerization is initiated either in the presence of light, heat, pressure or any catalyst. So this vinyl chloride on polymerization will form PVC. What is PVC? PVC is polyvinyl chloride. So this is addition polymerization. In this case, whatever product we are getting is just the exact multiple of the monomeric unit. So actually what is happening is an intermolecular rearrangement is taking place and double bond double bond is breaking, and we get, in the presence of light, heat, pressure or any catalyst, we get this polymer which is polyvinyl chloride. Next is condensation polymerization. In the case of condensation polymerization, polar molecules with small polar groups should be present in the monomers. Monomers should have small polar groups, and there will be elimination of small molecules such as H2O, HCl, etc. Some small molecules are eliminated in this reaction. I will give you an example of condensation polymerization. A well-known example is formation of nylon 6,6. So what are the monomers in the formation involved in the formation of nylon 6,6? The monomers are hexamethylene diamine, and adipic acid. So, in the case of condensation polymerization, two different monomers are used, and the monomers should have some polar groups. Okay. So hexamethylene diamine and adipic acid undergo condensation polymerization, and two molecules of H2O is removed. So when n number of these two monomers are reacting, what do we get? We get this is our nylon 6,6. Okay. Why the 6,6? Because in each monomer there are 6 carbon atoms. That is why it is called nylon 6,6. So what are the monomers involved in the formation of nylon 6,6? Hexamethylene diamine and adipic acid. So we have hexamethylene. That is 6 methylene groups are there and 2 amine groups are there. So it is called hexamethylene diamine. And this is the adipic acid, which is a dicarboxylic acid, adipic acid. So these two monomers co-polymerized, and what we get is known as nylon 6,6. So next we will see what is co-polymerization. copolymerization. Here it is also called, consider our styrene molecule, styrene and butadiene, 1,3-buta. These two combine together and form styrene butadiene copolymer. Structure is CH2 double bond CH, so this is our styrene butadiene rubber. Which is a copolymer which is having higher molecular weight. So today's class we have seen general we have understood what is a polymer, then what are nomenclatures involved in polymers, and then we have seen the types of polymerization reactions. Hope it's clear to you. Once again I will explain the types of polymerization reactions. Polymerization reactions are 3 types. Addition polymerization, in which the product that is formed is the exact multiple of the original monomeric molecule. In that case we saw example of vinyl chloride being converted into polyvinyl chloride. Next we saw condensation polymerization, in which case there is elimination of small molecules. Small molecules are removed in the reaction, and that is known as condensation reaction, condensation polymerization. For that example, we saw hexamethylene reacting with adipic acid and forming nylon 6,6. And finally, we saw copolymerization. Example of copolymerization, we saw styrene and butadiene reacting to form a copolymer, that is styrene butadiene rubber. Hope it's clear. Thank you.